Okay, so till now we've seen integration as a process, right? So it was a process of finding the area. But now onwards, as you progress, you'll soon be looking at integration as an operator. So if somebody gives you this sort of an expression, y equals, let's say, 5x square plus x cube, let's say, okay? So this is a function here, and somebody asks you to integrate this. So what you do is, so you can write it as a step, right? Integrating both sides with respect to dx, okay, with respect to x1, okay. So integrating both the sides, what you get is integral of y with respect to dx, okay. So y dot dx, so integral of y here, so if I integrate, so integral of y dot dx equals, now to integrate this whole expression, so what I write is integral of, so just instead of y I just plug in the whole expression here, right? So 5x square plus x cube in brackets dot dx. Now just like, so I'll be going pretty mechanical here, and this is also very obvious if you think about it yourself also. So I can simply distribute my integral on both sides. So when I have a addition sign or subtraction sign in between, I can actually find the I can distribute my integral. And what that means graphically is that, so I am first finding the area under this part of the curve and then adding the area under this part of the curve. So whenever you add two functions, so for example, if I have two functions, let's say the first function looks is a straight line, and let's say the second function also a straight line, okay. And when I'm finding the sum of both of them, so if I'm adding the two functions, what I get is at every point I'm adding the heights after all, right? So what I end up getting is this. And if I take two limits, for example this limit and this limit, and I find this area and add to that this area under the second curve, what I end up getting is the area under the third line, okay. So I end up getting the area under this thing. So that is pretty obvious, right? Because I've added the two curves, so I also end up adding the two areas also. So if I have to find the area of the area under the this line, I can simply find the area under this line and then add to that the area under the second line here. So that is what is being done here also. I can simply distribute my integral, okay. Just in the same way I was distributing my derivative, or I was distributing my derivative, I can distribute the integral sign here also. So what is becomes simply is y dot dx equals, so find the integral of 5x square dot dx plus integral of x cube dot dx. I can use the power rule here, so I just use my power rule here, and I can simply increase the power by 1 here. So this is a simple expression, right? And divide by the same number. So this is the integration of this. Obviously, because this is an indefinite integral, I need to add plus c, and I'll just write this as c1, okay, because I'll get another constant here also. And if I integrate, so if I integrate this, so what does this 5 do? The 5 makes my graph steeper by a factor of 5, and which also means it increases my area under the curve by a factor of 5, okay. So if I have x square, and then, so this is my x square graph, okay. And if I also have the curve of 5x square, so it will be steeper, 5 times steeper. And if I take the same limits, this area, so if I multiply this area with 5, I'll get the whole area here. So the area under this curve will be 5 times larger than the area under the x square curve, okay. So that is what this 5 does. So I can simply take this 5 out, okay, and because it will end up increasing, so whatever I get the area under x square, so what I can do is find the area under x square and then multiply that by 5. So what I end up doing is I take my 5 outside simply, okay, and this equals, simply I'll just write this here. And if I proceed, I can now use my power rule here also. This is a plus sign there also, okay. I can use my power rule again here, and what I get is y square dot dx equals 5 times, so I increase the power by 1, so I get 3 upon 3 plus c2, so the second constant of integration, plus x4 by 4 plus c1. And because the two are constants, I can simply add them up, and so I'll simply add these two up and write them together. Wait, I'll bring it here, okay. So what I've done is I've simply rearranged the terms and added the two constants of integration and made 1c out of them. So this is what I end up getting, okay. So now you've learned how to differentiate these sums also. Okay, so sorry, there was one problem here. This won't be x y square here. Okay, so that is just a mistake done by me. And yeah, so here you've learned how to integrate polynomials like these, and I hope, yeah, you can integrate all the polynomials of this form. Okay, so with that being said, I will end this video here. Bye.